Hey everybody, it's Miss Berry. In today's video, we're going over section 2.2, which is called Graphical Displays of Data. We're going to look at all the different types of graphs that you're going to be exposed to in this class. We'll also talk about some other graphs that you won't see in this class, but that are just as important. And we'll talk about how do you know when to use which graph, and then we'll go do a little bit of a deeper look at a couple of different types of graphs. So let's get started. All right, so whether or not, based on whether you're looking at qualitative data or quantitative data, that's going to determine what type of graph that you want to use to display your data. So sorry, I got cut off. For qualitative data, we're going to be using things like bar graphs, pie charts, and word clouds. All right, so bar graphs are going to look sort of like this. They will have little bars of different heights, and the most important feature that I want you to pay attention to is that the bars do not touch. Of course, we all know what a pie chart is. It'll look something like this. And then a word cloud, you might use this if you are trying to find like patterns in the things that people said as in responses to your surveys. And so you can generate these online, but it'll have, say you're doing a survey on, evaluations for a professor at the end of the semester. So the words that are the largest will be the ones that occur most frequently. So maybe it'll be like helpful will be really large on the screen. And then it'll be in smaller font things like office hours, or maybe a big issue for students was the exam, so maybe that's a bigger one. Or things like kind might be in smaller font. So the words that occur most often are going to be in larger font, and the words that occur less frequently will be in smaller font. When you are working with quantitative data, you might see things like line graphs. This is where you have a bunch of data points and they're just connected by sort of little line segments. Maybe it looks something like this. Then you have a bunch of little points out here, and then you would see the data connected by these little line segments. You could also see scatter plots. That's just going to be where you have the data plotted, just the points plotted. You will also see histograms. That's what we're going to be looking at in just a minute. Histograms look really similar to bar graphs, but in this case, the bars touch. All right, so with a histogram, which we're going to work with pretty extensively this semester, you're going to see that the bars touch. That's an important distinction between those two. You might also see something called a box plot. All right, box plots look like this. It'll have a little dot for the minimum value, and then the box will start at what we call the first quartile. There'll be a little line drawn at the median. The box will end at the third quartile, and then the line will be extended out to the maximum value. So it kind of just tells you where the middle 50% of the data lie. And then lastly, we have all probably seen lots of heat maps since the COVID time. That was a very popular time for heat maps. With heat maps, oh goodness, that wasn't what I tried to do at all. I'm just trying to draw like the shape of Georgia. That's not very good. But let's say that then maybe this is the state of Georgia, and then it's sort of split into its different counties. And I'm just making this up, right? And then if this was during COVID times, sometimes you would see that they had darker colors um, where COVID was more prevalent at that time, and then lighter colors where COVID was less prevalent at that time. So we'll stop there. And then so you might see like a dark red where COVID was very prevalent, lots of cases of COVID. And then you have like slightly lighter shades. I don't have very many color options right now, obviously. But so we'll just see slightly different variations in the color based on the prevalence of COVID or whatever the heat map is of that you're looking at. Right, so it would look something like that. It's a very crude drawing. All right. So let's talk about histograms. Just kidding, we're going to talk about pie charts. On the first day of class, so this is from a previous semester, on the first day of class, I collected surveys from 82 students and I asked them a bunch of questions. And this particular question that I asked them was, what year of study are they in? So are they a freshman, are they a sophomore, junior, or senior? So for this semester, I had 40% of the class were freshmen, 15% of the class were juniors, 40% of the class were sophomores, and then 5% of the class was seniors. We're supposed to find the number of students in Miss Berry's class that are in their junior year of study. All right, so from that last page, we learned that 82 total students were surveyed. 82 total students surveyed. And juniors, we said there were 15% of the class was juniors. So we take our 82, multiply it by 15%, which as a decimal is 0.15. All right, so we take our 15%. The decimal's right after the 5. It's not written there, but it's understood to be after the 5. And then we move it 2 places to the left, and that gives us the decimal version of that percentage, so 0.15. All right, 82 times 0.15 is 12.3. And our directions tell us to round to the nearest integer. So for rounding to the nearest whole number, the nearest integer, that would be approximately 12 students. All right. 12 students were juniors. All right, now let's find the number of students in the class that were freshmen that year. All right, so again, 82 total students. We know that we're looking at freshmen. Freshmen were 40% of the students that year or that semester. 40% as a decimal is 0.40 or just 0.40. You can leave the 0 at the front off. All right, so we take 82 times 0.40. 82 times 0.40 is 32.8. If we round that to the nearest integer, the nearest whole number, that's going to be 33 freshmen. All right, so super easy to read a pie chart, as long as you know the total number of people surveyed. Now we're looking at the histogram. All right, so we have a histogram here. This was from a previous semester. This was the Unit 1 exam scores for 94 students that were in my stats class and took the exam. We're going to use the histogram to answer the questions. So you can see we're just noticing some things about this histogram. No one scored in the 35 to 45 range. We had, looks like the highest number of people scoring between 105 and 115. And then we had about 15 people, for following that line, 15 people scoring between a 95 and a 105. And then this is sort of halfway-ish between 15 and 20. These are the folks that are scoring between a 75 and an 85, and an 85 and a 95. Looking at between 65 and 75, we had about 15 students scoring between a 55 and a 65, or excuse me, a 65 and a 75, my bad, sorry. And then between 55 and 65, we had 5 students scoring in that area. And it looks like maybe one scored between a 45 and a 55, and then one scored between a 25 and a 35. All right, so it says find the number of the class containing the largest number of exam scores. All right, so the class is going to be like, this is class 1. So let's write that down there. This would be like class 1, class 2, class 3, 4, 5, 6, 7, 8, 9. So which one had the largest number of folks in their little rectangle? That would be class 9, right? So class 9 had the tallest column, or the tallest little rectangle. Find the upper limit of the 5th class. All right, so let's label these again. 1, 2, 3, 4, 5. All right, 5th class, our upper limit, just accidentally drew over it. Our upper limit for that 5th class would be 75. All right, so super easy, just reading that off of there. All right, the class width for this histogram, remember to find the class width, we're going to do the difference of, do y'all remember? The difference of 2 consecutive lower class limits. All right, so let's just do the first 2. So we would do 35 minus 25. So the class width is 10. So we're just doing the difference of 2 consecutive lower class limits. So that was a definition from, let's see, what section was that? Maybe 2.1. All right, and then last, find the percentage of students who scored a 95 or higher. All right, so the percentage of students who scored a 95 or higher. All right, so we're looking at people here. All these folks. Right, we know that there are 15 people that scored between a 95 and 105. Just following this little line across. And then between a 105 and a 115, there were 20 people that scored in that range. So 20. All right, and then we're going to add those together. So there's 35 total that scored a 95 or higher. All right, I had to go back and check. There was 94 students that took this exam. 94 students total. All right, so 35 over 94. 35 divided by 94 is 0.37. I was just go ahead and converting it to a percentage in my head. Sorry. 0.3723. Right, convert that to percent form. So take your decimal, go the opposite direction. If we were going from percent to decimal, we move the decimal to the right. We're going here from a decimal to a percent, so we're going to move it 2 places to the right. So that's going to be 37.23%. We're supposed to write that to the, or round that to the nearest percent. The 0.23 tells us not to round up, we'll just stay at 37. So 37% scored a 95 or higher. Lastly, we are looking at stem and leaf plots. You don't see these used a whole bunch in real research, but this is another good way for us to practice working with data sets. It says the following stem and leaf plots represent the ages of students in my stats class from a previous semester. All right, so we have our stem on the left and our leaves on the right. Stem and leaf plots are really useful when you have a lot of repeating values. So you can see we have a lot of people who are, remember, the stem is going to be the tens place, the leaves are the ones place. So if you're thinking about place value, like this first person would be a 1 in the tens place, 7 in the ones place. So that'd be 17 years old. Right, so if you are thinking about the ages of my students, we have one person who's 17, we have a bunch of people who are 18, bunch of people who are 19, bunch of people who are 20, a bunch of people who are 21. Then we start tapering off. We've got a 122-year-old, 3 23-year-olds, 2 24-year-olds, 1 25-year-old, 1 27-year-old, a 30-year-old, a 35-year-old, a 38-year-old, and a 39-year-old. All right, so the stem in this case represents the tens place. The leaves represent the ones place in our ages. All right, so how many, just looking at our stem and leaf plot, how many people in the class were in their 30s? Where are my folks in their 30s? Here's my 30s. All right, so we had 1, 2, 3, 4 people in their 30s. All right, so 4 people in their 30s. Next, what is the age of the youngest person in this class? All right, so the youngest person this semester was 17 years old. And then how many people are between 20 and 40 years old in this class? All right, so here starting at 20, ending at 39, we're going to count all these people. Each little digit, each little leaf represents a person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Whew, okay. Pause that and count on your own if you need to. But that was 40 people. 40 people that are in between the ages of 20 and 40 years old. All right, and then lastly, we've got a little bar chart here, bar graph. You can see I do have one little mistake here. This is a hospitality and tourism, and then hospitality. I should have combined those into one bar, but it's okay. It says, the following bar graph shows majors of students in my class. Use the bar graph to answer the question. So you can see we have lots of nursing students this semester. I think I had a learning community that semester. So I had a lot of people who were in the nursing program. And then my next most popular major looks like biology. And then psychology and education are really close. I can't tell if they're exactly the same or not. I think they are. All right, what major is the most common among Miss Berry's students? That would be nursing, right? Nursing is the most popular major this semester. And how many students are education majors? This is easier to do if you have this printed out, but you would just go to the education bar right here, and then we're going to follow that down. We're going to try to follow it down in a straight line. Boom, there we are. All right, so let's count down from 10. 10, 9, 8. 8 students were education majors. All right, so that was a little overview of some different types of graphical displays of data. If you have any questions, please let me know, and I'll see you guys in the next one.